going to learn what's called the shell method. Okay. We are going to be rotating around different axes to create three-dimensional solids, and we're going to find the volume. But now we just have a different method for it. Okay? Now, what kind of rectangles did we need when we did the disc washer method? How were they in relation to the axis of rotation? So if we were rotating around the x-axis, they were perpendicular. Okay?
I know.
Well, now we're going to take parallel rectangles and rotate them around an axis of rotation. So now that we have two different methods, Mr. Griebel hates this, but he uses it, so I think he secretly loves it. In order for you to keep them straight in your head, I like to call them the perpendicular and parashell methods. Okay? Whether you use this or not. Well, I know. But, you know, disc, washer, potato. It's the same method, right? Brem, you don't like this? No? Okay. But what you need to understand by me doing this silly word thing, when we use the disc washer method, we have rectangles that are perpendicular to the axis of rotation. And when we use the, I really don't like the perpendicular washer. Okay. But when we use the shell method, parashell, okay, we need rectangles that are parallel to the axis of rotation. Okay, I agree with you. The washer, that did it. But if you remember perpendicular, you know that disc and washer are the same. Okay. So we're going to work on taking a figure, rotating it around an axis of rotation, but we're going to use parallel rectangles. Okay? Why? Sometimes it's easier to do it in dx, or sometimes it's easier to do a rotation in dy. And so if we have the option between which kind of rectangles we can use, it just gives us more flexibility to do what maybe takes less time. Also, if we have to do some things by hand, there are times where squaring binomials is a lot of work. You'll see that in the shell method. We don't have to square anything, which makes it a little bit nicer. Okay? So what I want you to imagine is, and you don't have to draw this, just want you to imagine it. Okay? Let's say we have a region. Okay? And I take a rectangle and we rotate it around the parallel axis. So we're going to rotate these around. Okay? So what are we creating? We're creating basically like cups, right? Okay, you were a kid once. There was like those cups that like stacked inside of each other, right? That's basically what we're creating. Okay, so these are going to wrap all the way around, and what's going to happen is you're going to have something that looks like this. Okay, like a toilet paper roll. Okay. Now, let's talk about how we would find the volume of this. So what I want you to do is I want you to imagine we cut this and we draw it out as a rectangular prism. Okay. Okay. So this shell has height, which would correspond to this right here. long is this? Say that letter. That's the circumference of whatever that circle is. And how do you find circumference? Or 2 pi r. Pi d, 2 pi r, same thing. Right? Okay. And then we have like this width right here. Okay. Excellent. So the volume of each of these shells is going to be 2 pi r times the height times the width. Okay? Still, we don't need to be writing down yet. I'm kind of showing you how we're getting the formula that we're going to use. Okay? All right, so let's go back to my picture. The height is corresponding to the height of this rectangle. How do we determine the height of this rectangle? Top minus bottom. Okay, whatever our top function is, maybe it's called f, minus our bottom function, maybe it's called u. Okay? And what is the thickness of that rectangle? In this picture, our thickness is dx. Okay? So what's going to happen is we're going to get, I guess I need to go back to, so the height of our function is top minus bottom. Now the radius, in this instance, we're going to label as x. Let me come back to my picture here. Any rectangle that I draw is going to be x away from the y-axis. You see that? No matter what rectangle I were to draw, doesn't matter where it is, it's x away. And then just depending on where we are, we can plug in different values for it. Okay? So our shell method is this right here. This is what you can write down. Our volume is 2 pi, integral from a to b of x, that's our radius, f of x minus g of x, that's our height, and then dx is our thickness. What do you mean by rotate it the other way?
So like your picture, you're using dy?
Yes. So if we were using dy's, same thing, we'll just do right minus left instead of top minus bottom. Yeah. And that's what we will do today. Today we're going to focus on just rotating around the x-axis and the y-axis. Tomorrow we'll focus on axes of rotation that are not the x or y axis.
That's what our quiz is.
Our quiz will be on this along with the dishwasher method. I want you to practice using them both at the same time. Whether I say do this with the dishwasher method or do this in terms of x, and you have to figure out what method it is. But we'll work on that Wednesday together. Okay? That's 2 days away. Okay? So today, let's see, I have 3 examples that we're going to do. Okay? We're going to go through how to set these up, both in terms of x and in terms of y. So our first example is actually this picture right here. And I really want to show you this, but I'm afraid it's going to mess up my recording. Last time I did a PowerPoint, it didn't do my recording. But maybe when we're done, I'll show you that little image. So here's our first example. We're going to take y equals 0.5x and y equals x minus 1, the quantity squared, and we're going to rotate it about the y-axis. And start drawing your picture if you haven't already. So here's the region we're going to rotate around the y-axis. Okay, so we're working on the shell method today. So all of my rectangles are going to be parallel to the axis of rotation. Okay, parallel, shell, rowing. I know it's Monday morning. A little bit slow to wake up. Is this anybody's first class of the day? It's not, is it? Okay. So at least you sat through at least one or two classes. Okay. So biggest part about this problem right now, I need to know these x coordinates of intersection. Has anybody worked on finding them? Ooh. What are they?
Those will be 1/2, 1/4.
Okay.
And the other one is 2.
Okay. So, since we're doing the shell method, our integral needs to be 2 pi r h thickness. So here's my 2 pi. Our radius, all of those rectangles are x away from the y-axis. And then our height is literally the height of these rectangles. So if I look at each of these rectangles, they have height of top function minus bottom function. So this is radius, and this is height. And then since Braden found us our points of intersection, our integral can go from 1/2 to 2. So what you can do for me, okay, and let's talk about putting this into our calculator, okay? You know that I like your answer to be in terms of pi if possible. Like if it's going to be a fraction times pi, I like that. Now there's a 2 pi out in front. So either you're putting this into math 9 and then multiplying it by 2 pi, or if you want to put 2 times the integral and leave out the pi until the end, I'll let that be up to you. I just don't want you to forget about the 2 pi. So get 45 pi over 32. What's on here? 9 pi over 8? you have top right as bottom, but you see how there's like that X out of it?
yeah.
So, anyone else have issues getting to 45 pi over 32? Okay. Does anybody have any questions on this setup? We'll do another one, but you be okay?
Yep.
Okay. You get there, baby? Yeah. Yeah. Maybe. Yep. This year I have 11. Last year I had. How many did I have last year? I think my biggest class has been 15. My smallest class has been 5. So that's when like I first started teaching it. Okay. Here's our next one. A lot has changed in terms of how people have practiced since I first started teaching it. There were 2 years where I had Monarch kids drive over here to take the class. So I had, yes, and then my husband started teaching it over there, so now they don't have to drive over. But,
Wait, your husband teaches in Monarch?
yeah, he teaches. Yeah, he teaches math over there. So when we met, he was teaching at W East and I was teaching at W West. So we've always just operated as rivals. It just works better that way. Yeah, that's not a lie. So they can bring a toy with them for indoor recess. Case definitely brought a calculator for a week. You know, it was entertaining to him.
You tell me he like drops it and he breaks it and you're like, oh.
Well, it was one of those like calculators you get at a parade, you know, like those. But they do really enjoy. Like it's a treat when they get to play with our like graphing calculators. Yeah.
So are your boys going to Monarch? Is there anything?
Yeah. As of right now, that's their chocolate thing. We literally live in walking distance of the elementary school, middle school, and high school. So, I mean, it makes sense. And if my husband's there, then. But, yeah. Well, I still like, I'll bring Case with me to like basketball games, and he still cheers for the Titans. He told me he likes the Titan boys basketball, but the Monarch girls. Well, I think it's probably because he gets high fives from the Titan players. That's why the boys win over. But. Okay, so this is our. What? You want high fives after a game?
I want to watch them get high fives. That's so cute.
Oh yeah, they like stand outside the locker room and they wait. Okay, so I want you to imagine what this looks like. Rotate this around. What is this gonna look like? You're like look like a bundt cake, right? Can you imagine it?
Yeah,
Bundt cake? Okay.
a bundt cake.
A bundt cake? Do you know what a bundt cake is? What?
You are living.
Oh.
Somebody please explain.
No, I'll show you.
Okay.
I love your cats.
Okay, so we know we're going from 0 to pi. Notice how our rectangles are parallel to our axis of rotation, so we're using shells. Go ahead and put it in the basket for me. We're going from 0 to pi because, I mean, it literally told us we didn't have to, like, make a guess on that. Okay? It said from 0 to pi. So our shell method, we have 2 pi, our radius. Every single rectangle I would draw is x away from the y-axis. So x is our radius. And then the height of each of these rectangles would be what? Sine of x minus 0. I'm not going to write minus 0. Okay. Now this is one you would have to use Math 9 on. Those of you who take Calc BC next year, I will teach you how to integrate x sine of x. It's actually one of my favorite methods of integration. One of my favorite things to teach, actually. I can't remember if this is in my sentence or not. It's 2 pi squared. It's 2 pi times pi.
Yeah.
So you get 2 pi squared. What is that approximated? Like, it's totally cool if you don't recognize that that's 2 pi and write 2 pi squared.
19. What is pi?
3:14. It's a Saturday. It's the Saturday that we begin spring break.
Hopefully we'll be playing. Hopefully we'll be playing in the state basketball game.
All right, last example. Go ahead and write this down and draw the picture. We have to wait till Tuesday night. So the games that we care about are the U.S., the Philippines, oh, because yeah, there's going to be some that are done. Yeah, that's not a problem. Well, and the West Side game isn't until Tuesday. Right?
That's the one I'm most worried about.
Yeah, that's probably the most winnable game. Yeah. Max, what's this point of intersection right here? Put 2, 4. So 2 squared and 2 times 4 are both 4? Okay. $4.60. The 2, 4 is, it's right? Okay, so I'm asking you to rotate this around the x-axis. Yeah, we could do this with a disc or the washer method. But let's just see what the shell method would look like and why that might be a better option or not. Okay. So if we're going to use the shell method, notice how we drew a rectangle parallel to our axis of rotation. It has thickness dy. Okay. So we're going to set up our integral 2 pi integral 0 to 16 because we have to use the y limits of integration. Okay. Now our radius is going to be what? Y. All of those rectangles are y away from the x-axis. And then the height of each of these rectangles is going to be right minus left. So in terms of y, our right function is radical y minus our left function y over 4. Thickness dy. So 2 pi r h. Yeah, 1/4 pi y over 4.
No, no. Okay.
Yeah, it is.
I was thinking what
Alright, and here calculator buttons. Are we getting anything nice? Okay.
I got what, so we got 2048.
I got
2048 pi
Over 15.
over 15.
That's probably the
Okay. Yeah, so you'll find that sometimes your calculator approximates just right to where it can't get it to the fraction, and that's okay to give me a decimal. Like there's nothing wrong with that. If you can get it to a fraction, please do. If it's a decimal, and you saw this on your quiz, if you were one of them, if it's a decimal, do not put a decimal times pi. But there's this. It's either a decimal or it's a fraction with pi. No one uses it. Okay, so in this particular example, you may not see the benefit of shell method versus dishwasher because I think the integration by hand would be just as easy. The setup is just as easy, okay, relatively speaking. But when we get into rotating around different axes of rotation, sometimes the shell method can give us a nicer setup to where if we have to do it by hand, it's not, we don't have to square by hand. Okay. So your homework this evening, same thing, there are some that I want you to do by hand and some that I'm fine with you doing Math 9. This quiz that is on Thursday, this will be a quiz where it's part calculator, part no calculator. Okay? I'll make you do some drawing the picture, setting up, maybe some integrating without your calculator, and then you'll turn that in, and then you'll do some with your calculator. So know that that is coming as a part of your quiz. So we have about 8 minutes left in class. If you maybe want to try to set up 1 or 2 of these, that might not be a bad idea before you walk out of here. I'm gonna